why sometimes it makes that noise and usually it doesn't. I like when it does, because then I know it's recording. Hi, recording. Okay, throw your name on here. This is currently second hour. Thank you. All right, so this week is all about learning all 3 different ways we can find slope. So in 2.1, when we found slope, we counted on our graph. What did we count on our graph? We counted something over something. Rise over run. Yep. So in 2.1, we did rise over run. So how far up and down you go, how far left and right you go. In 2.2, we looked at the change in our y values. So how much are our y values changing? Y values changing. Over how much are our x values changing. So our shorthand way of writing that was change in y over change in x. We use that delta to represent change. Okay, today how we are finding slope is using the slope formula. So I think actually Avery told us this on Monday. It is y2, so that's a y with a little 2 behind it, minus y1 all over x2 minus x1. So that is the formula for finding slope from an ordered pair, 2 ordered pairs. So this is a good method to use if your ordered pairs are really, really far apart. Because if I have to graph a point that's here and a point that's all the way up here, and then I have to count, and I have to count up 87 and over 92, I'm probably going to make a mistake if I sit here and count that many individual squares. It's also good if you don't have access to a graph. This is what you would want to be able to do. So what the y2 and y1 mean is it's y from my second ordered pair minus the y from my first ordered pair over the x from my second ordered pair minus the x from my first ordered pair. So you look at x and y from your 2 ordered pairs. Okay, and I put a hint there, label your x's and y's. It's going to make your life way easier until you get the hang of this. Once you get the hang of it, if you can do it without labeling, I'm not going to make you. But here at the beginning, label them so you know where things are coming from. The first thing that we're going to do is we're going to label these. These are x and y from my first ordered pair. So I'm going to label these x1 and y1. They use this all the time in pre-calculus. So this is x and y from my second ordered pair. I've also helped some of my kids who are taking geometry, so that's what you guys will take next year. Also help geometry kids with this year too. So if you're using it sophomore year and you're using it senior year, go ahead and bet you're going to use it junior year too. Okay, so then we are going to plug all 4 of those numbers into our formula. I'm going to rewrite my formula right here just so I have it. y2 minus y1 over x2 minus x1. Okay, what is the y from my second ordered pair? We labeled them. 3. So that's that 3 right there. Y from my second ordered pair is 3. Minus the y from my first ordered pair is 1. So 3 minus 1 is on top. Over on bottom x2. So x from my second ordered pair is 5. Minus x from my first ordered pair is 2. Okay. On top, we have 3 minus 1, so we just do the math. 3 minus 1 is 2. On bottom, 5 minus 2 is 3. And then we check and see if that can be reduced. Can we reduce 2/3 at all? No, there's nothing we can divide both 2 and 3 by. So our slope is 2/3, and then we are done. Okay, I do need you guys to show work of where you're getting this from. So you don't have to write the formula every time, but I do need you to show this. 3 minus 1 over 5 minus 2. So show the math you're doing before you get it to your answer. Alright, one thing I want to point out. When we do y2 minus y1, that is the difference between our two y values. That is the change in our y values. That's how much we rise. So all of this rise, change in y, y2 minus y1, that's 3 ways of saying the same thing. Okay? Same with run. Run is how much we go from left to right. Change in x is how much we change from right to left, or left to right, whatever. x2 minus x1 would be the difference between our x values, which is how much we change on our x-axis from left to right. Okay? Next one, go ahead and label. So we've got x1 and y1. We've got x2 and y2. Okay, so y2 minus y1, I've got my formula here, I'm not going to write it again. y2 minus y1 would be negative 4 minus 2. So my y2 is negative 4, and then it's always minus in my formula, so it's minus 2. Over, what is my x2 value? 3. Minus, what is my x1 value? Negative 1. Yeah, okay, that's what you said. I didn't hear you for a second. We have to do 3 minus negative 1 on the bottom there. Because the formula says x2 minus x1. If x1 is negative, then it's minus the negative. So there's a minus that's part of the formula, and then a negative is part of the negative 1. On top, negative 4 minus 2. I take $4 from you, and then I take another $2 from you. I have taken $6 from you. I'm going to go to lunch. $6 can't even get you lunch barely anywhere these days, though. Okay, on the bottom there, 3 minus negative 1. What does subtracting a negative mean? Adding. So subtracting a negative is the same thing as adding. If I take away a bad thing, that is good. So 3 minus negative 1, same thing as 3 plus 1, it's 4. So I've got negative 6 over 4. Okay, can that be reduced? Yes. What can I divide both 6 and 4 by? 2. So I can divide the top of my fraction by 2. I can divide the bottom of my fraction by 2. Negative 6 divided by 2 is negative 3. 4 divided by 2 is 2. So I get negative 3 halves. Yeah?
I'll bring it back.
Oh, that's just a pass for you to come get a calculator. Yeah,
Yeah.
grab one from the bottom row and then bring it back.
This side.
Yes. Hey, I just got a text from my brother. He survived the hurricane. This is the first I've heard from him today. He lives in Tampa. Congratulations to my brother.
Do I need to get a shirt?
I'll get it for you later. Text me. Okay. Hey, any questions on either of those problems so far? Hey, we've got one more. What do you guys notice about this one down here and how I have it set up? Be quick. I've got a graph. What else do I have? A little table, a little chart like what we saw yesterday. And I've got my formula. The reason why we have all 3 of these things is because this week we have learned how to do the same thing 3 different ways. So I want to show you with one set of ordered pairs, we can do the same thing 3 different ways. Okay? So let's graph it first. Let's go in order of what we did this week. Negative 2, 4. That means I'm going to go left 2, up 4. So negative 2, 4. And 6, negative 2. I'm going to go right 6, down 2. So even these that are both on this graph still seem kind of far apart. Kind of seem like a pain to count, to be quite honest. I'm going to connect these. And then count. Whoop. So, it looks like, first of all, is this a positive or a negative slope?
Negative.
Negative. As I go from left to right, I'm going down a mountain, not up. So I go down 1, 2, 3, 4, 5, 6. So down 6. And then I go to the right. 1, 2, 3, 4, 5, 6, 7, 8. So I go to the right 8. So what would that make my slope? Negative 6 over 8. Let's write that down right here for a second. Yeah, we will simplify it in a second. Let's simplify it once all at the very end. Okay, so that's what we did in 2.1. If you want to put a note to yourself there that that's 2.1, you can. Okay, in 2.2, I gave you guys a bunch of tables that were already filled out. 2.2. We, however, can fill out a table ourselves. So this is xy, this is xy. So I can just put these two ordered pairs on this table. So my first ordered pair is negative 2, 4. My next ordered pair is 6, negative 2. And then we can just find the change in our y values and the change in our x values. How much did I go down from 4 to negative 2? 6. 4 minus 6 is negative 2. Okay, from negative 2 to 6, how much do I have to go up? 8, because it's 2 to get up to 0, and then another 6 to get up to positive 6. So I went up 8 here, which once again, change in y over change in x would be negative 6 over 8. So I've gotten the same thing again. Okay, the last way we could do it was with the formula, and that's what we learned today in 2.3. So with the formula, I would do y2 minus y1, so negative 2 minus 4 on top. And then I would do x2 minus x1 on bottom, so that would be 6 minus negative 2. Negative 2 minus 4 is negative 6. For the third time, 6 minus negative 2 is going to give us positive 8. Oh my gosh, we got the same thing 3 different times? Crazy, okay? So the reason why we're showing you this is there are different times when different things will be useful. If you have access to a graph and the points are close together, just graph them. If you are a person that always messes up your x's and y's when you're graphing, don't choose graphing. If you are a person who is good at just plugging things into a formula and following steps, do it. If you're a person that always messes up your negatives when you're adding or subtracting, don't do it, okay? Most people like this method or this method. Not many people choose to do this, but if you want to, you're more than welcome to. Last thing we need to do with this, what can we divide both 6 and 8 by? 2. So I can divide the top by 2 and the bottom by 2. Negative 6 divided by 2 is negative 3. And 8 divided by 2 is 4. So I get negative 3/4 is my final answer that I have now gotten 3 whole times. All right, any questions? Okay, I'm going to keep recording while I say this, so it's in the video for people who are gone. Your assignment has 8 problems on it. The 4 on the front, you have to use the formula. We want you to use this formula. We want everyone to try that 4 times. So the 4 on the front tells you you must use the slope formula. On the back, you can use the slope formula, make yourself a little table, or graph it. You do not have to do all of those things. If you don't have to do the same thing the whole time, you can though. You pick your method on the back. So front side, you have to use the new formula. Back side, you can do whatever you want. You just got to show your work for at least one of the methods. Okay. Bye, video. Nice knowing you.